There is so much to probability, and today we're going to look at something called dependent events and independent events. Let's start with independent events. When we're looking at independent events, it means that whatever happened in event A has nothing to do with what happens in event B. So an example of this is, say that I have a coin and I flip the coin and I get a heads. But then my event B is I then have a number cube and I roll a 5. Well, the flipping of the coin and rolling of the die have nothing to do with each other. They cannot affect the outcomes. That would be an example of those independent events. Now, dependent events, whatever happened in the first event absolutely affects what happens in the second event. An example of this is, say I have a sock drawer and I go and I pull one sock out and I put it on my foot. Well, now there's fewer socks in the drawer, so it absolutely affects what sock I can pull the second time because that first sock is already out. That would be an example of dependent events. They change the outcome of the second event. So we can calculate probability of both independent events and dependent events. So let's start with our independent events. Now, we know how to find individual probability. So when we calculate independent events, we're going to find the probability by itself of the first event. We're going to find then the probability by itself of the second event, and then we multiply the two events together to get that independent probability. So here's an example. What is the probability of rolling a 5 on 3 different number cubes? Now, a number cube is always just a die, but in math they always say number cube. So I always set up my problem where I want to see what is going to happen. So what's the probability of getting a 5, then a 5, then a 5? And when we do this, remember, each event is separate. Well, the probability of getting a 5 on the first number cube would be 1 out of 6 because I have 1 5 out of the 6 numbers. The probability of getting a 5 on the second number cube would be 1 out of 6. And the probability of getting a 5 on the third number cube would be 1 out of 6. Now remember, it's 3 different number cubes. They cannot affect each other. So then in order to find the probability of a 5, and a 5 on the 3 number cubes, we would multiply the ratios together. Now remember, we're going to multiply all the top numbers, so 1 times 1 times 1 is 1. Then we're going to multiply all the bottom numbers, 6 times 6 times 6, which is 216. So the probability that I'm going to roll a 5, and a 5 is very remote. It's only 1 out of every 216 tries. That's phenomenal. So that's independent events. Let's go to a dependent event. Now, dependent event, remember, whatever happened in the first event absolutely affects what happens in the second event. And so when we go to find the probability, they say, well, find the probability of A, and then it says find the probability of B given what happened in A. So what does that mean? Well, let's take a look at an example. So say we're in art class, and that art class has 8 boys and has 10 girls. So we have a total of 18 kids in the art class. And the art teacher decides to choose 3 kids randomly to stand up and show their artwork. We want to find what's the probability that she's going to happen to choose a girl and a girl and a girl. So first we're going to find the probability of the first girl. Now remember, we haven't taken any kids yet. So we have 10 girls out of the total class of 18. But the first girl gets chosen and she's on the side ready to show her work. She's not being in the group anymore. She can't be chosen again. So that means now I don't have 18 kids to choose from. I only have 17 kids. And because she already chose one of the girls, the number of girls reduced from 10 down to 9. So here we can see that dependent event because it absolutely changed the probability. So then she picks the second girl. So now we've got 2 girls standing to the side. Well, now I don't have 18 kids to choose from. I don't have 17 kids to choose from. What I have left sitting in the classroom is I have 16 kids. And my girls reduced again because I have 2 girls already standing up. So now I only have 8 girls that are available. So we can see that each event absolutely affected the next event. So now all we have to do is do our multiplication to find our probability. So we're going to do 10 times 9 times 8, which is 720. And we're going to do 18 times 17 times 16, which is 4,896. And whenever I get a big ratio like that, I always look at it and think, can I reduce it? And you absolutely can. We can divide both the top and the bottom by 144. So I get the probability of getting a girl, and a girl just chosen randomly as 5 out of 34. So this is certainly the more complicated, and we have to recognize that actually one event is affecting the other. So I thought, let's take a look at a second example. Let's go back to our socks. So we know that once we take a sock out of the drawer, it affects how many socks are still left in the drawer. So let's say I have 3 pairs of socks in a drawer, so I have 6 socks there. And the socks are a brown pair of socks, a blue pair of socks, and a black pair of socks. Well, I want to know the probability just randomly. Let's say the lights are out, that I'm going to put my hand in and pull out a brown sock and put it on my foot. And then I'm going to draw a second sock out, and it just happens to be the second brown sock. Well, the total number of socks I have are 6, and 2 of those 6 are my brown socks. So when I pull the sock out, I put it on my feet. Now I don't have 6 socks anymore in the drawer. Now I only have 5 socks in the drawer. And because I have 1 of those 2 brown socks on my foot, that means I only have 1 left in the drawer. So my probability of the second event goes down to 1 out of 5. So now I multiply them together. 2 times 1 is 2, 6 times 5 is 30. I'm going to reduce those to lowest terms, so I get 1 out of 15. So dependent events, you've got to be careful to change that second or third event, always taking into account what happened. But that is how we find probability of our independent events and our dependent events. Good luck. It takes some thinking to do this, but I know you'll do well.